Ready to rock and roll. So, what do we think is going on here? What might our domain be for this one? Think about our smallest possible x value we can use and our biggest possible x value we can use. Let's see. What do we think? I was gonna say, if I'm with you on that. I was gonna say, because -4 is where we have our last kind of dot over here, right? We can go all the way over here. If we had an arrow on this, that's when we'd have like an infinity kind of situation. Since we don't have any arrows, let's just go with that -4. I don't have anything smaller than that. So our smallest piece for our x's is -4. What is the biggest x we can have where we haven't missed anything in between? And it's going to feel like I'm asking you a trick question. What do you think? What's the biggest x? On this segment, absolutely. Our biggest one here is 3. If you want to do it into 2 segments, you can. So if you want to put it as -4 to 3, which we have that open circle, so we're going to do this because it's not closed. So that would be if you want to do just this piece here. What would our domain for this piece be then? From 3 to 4. But this one we can touch 3. So I can do it as a square bracket for 3 to 4, like this. That does them as 2 separate pieces. But what that really means, if I go from -4 to 3, that I can't touch, but 3 I can, and then 4, this is the same thing as if we went from -4 to +4. I do have a value at 3. It has a jump here, but it's not skipped over. It's not a lava pit that we jump over. We just use a teleport right here. What's our range on this one going to be? So either of these is fine. I would take either one of those. They're both fine. So our domain had everything to do with our x's. Our range has everything to do with our y's. We need our smallest y and our biggest y. -3, heard that one. And we have our closed circle, so we're going to use our square bracket. And our biggest y, 2. And we can have every value in between from -3 to 2. Just like that. So then there were a bunch of questions like this on the homework, but we didn't really discuss it. This is kind of an algebra review thing from Algebra 1. What is the value of y when x equals 1? How do we find that? What is the value of y going to be if x is 1? So think about x is 1 is right here, right? So I want to know where our function is when x is 1. Well, that's going to be that guy right there. So y is 2 when x is 1. Y is 2. So we find our x of 1, or if it asks me what happens when y is -2, that would be done here. We put this way. So if x is -1, we put here. Y is -3, we put here. Lots of different ways we can look at that piece. But it's doing kind of a graph reading situation. So it's a little bit more of an Algebra 1 review. And then number 2, we've done one like this before, where we have to do some substitution. We did one like this yesterday. So what do we get when we substitute in our a of -4, our b of 0, and our c of 6. Yeah. You should get 96. Anybody did not get 96? Do you know what happened or what's going on? I have to double check it. Make sure if you did not get 96 that you watch out for negative signs. This -4 would be the reason it's positive. So just be careful, okay? Questions on this? Awesome sauce. So we are going to be working in our notes packet again. Shock, I know. Oh my gosh. We're going to be on page 4. So we're going to talk about when things are linear functions versus when they are nonlinear functions. So we're going to do this page today. We're going to do page 4. And then I think we'll get just barely into page 5. But I think we'll be okay on it. So we have this stuff kind of like half filled in for us. We've got a lot of information here. First things first, what do we think the words linear and non-linear mean? What does linear kind of look like it's got stuck in there? What do you think? What is a linear function going to look like? There's a clue right in the word. A linear function is going to be a line. It'll be a straight line. I can hold a ruler against it. It's a straight up line. A linear function must be a line. So in order for something to be a line, it has to have no variables raised to a power other than 1. So it can't have any x squareds or square roots of x or any of those kind of vibes. We can always write them in the form, what's the equation for a line? You remember? Y equals mx plus b. Oh my gosh, that guy's back again. Ew, gross. Oh, I know. Shock horror. And then a graph for this will be a straight line. So linear functions always look like a straight line. No little squiggles, just lines. Linear functions may not always be written as a y equals mx plus b, but if I can make it look like this, then it counts as a line. So sometimes it'll show it, we will be given the equation in the general form or the standard form. I'm going to put that off to the side over here just so we can see it. Just because we'll have times when we see it again. That would be when we have one of those ax plus by equals c, which that c doesn't show up at all. So this is also going to be a linear function as long as there's no exponents on those, because I can always solve that around to make a y equals mx plus b. So anything that is nonlinear is going to have some variable raised to the power other than 1. So it might have squares, it might have cubes, it might have all kinds of weirdo things. It can't be written in the form of y equals mx plus b. Oh my gosh. and the graph will not be a line. It will be in some way wiggly, squiggly, curvy. So it's really important, especially when we get to the point that we're starting to draw stuff, if we need to, use a ruler. Straight lines are very difficult to draw by hand. Utilize tools. Use the ruler. Okay, so we're going to be looking at some and we're going to decide if some of these equations are or are not going to be functions for us. But before we start looking at any graphs or any equations, we're going to talk about a couple of special kinds of lines. So let's think about vertical lines. If I have a graph, with a vertical line on it. Boom. Huzzah, my line. Everyone. So we're going to pretend it's a straight line because, you know, magnets are awesome. Is that a function? Because how do we test if something's a function? Vertical line test. A super duper high tech fancy schmancy math tool. The stick. Vertical line test. If I pass this in front, do I cross more than one dot at a time? Like, none, every single dot ever. Nothing. So I cross all the dots in one fell swoop. So it fails the vertical line test just because it is the vertical line. So vertical lines are not functions because they fail the vertical line test. Do you remember how we write the equation for a vertical line? It's okay if the answer is no. Like sometimes I ask questions. The equations for vertical lines are always going to look like an x equals some number. So x equals 2, x equals 7, x equals negative 12. X equals 3.4159256. So it's x equals something. So if you have x equaling a number, that is a vertical line, and that is not a function. We use it as a tool for things, but it is not a function in itself. Then let's think about horizontal lines. What is the equation for a horizontal line? So if I instead went, okay, mine's not going this way. Horizontal line. Now it's going that way. Except they're shorter. How do we write the equation for a horizontal line? It's a y equals a number. So horizontal lines say y equals some number. So are they functions? Yeah. If I pass my vertical line test across my horizontal line here, we got a vertical line test that's passing. It's only ever crossing one dot at the same time. So it is a function. So what next is it a one-to-one function? Not a one-to-one function. Good. Just kind of repeating on that one. So it is a function. They pass the vertical line test. And it's always going to be a y equals a number for that. So this also is going to be a line. Partly we can tell that because it's called a vertical line. Big clue right there. But also because, remember what we needed to have in our equations? Is we needed no variables with powers higher than 1. So if we had something like y equals 2, which is essentially what my little red line on the board over there is, I do not have any variables, so no x, no y, with a power bigger than 1. So it doesn't have to have a variable to be a line. Same thing with our vertical line. It does not have any powers bigger than 1, even if we had x equals 2. It still does not have any powers bigger than 1. So they do still count as lines. They're also called lines, which is a big old clue. So what we're going to do now is we're going to look at the 2 equations at the bottom of page 4 and the 3 graphs on the top of page 5 to start about, are these things linear or nonlinear? I know there's a huge space right there after are these linear or nonlinear. Formatting's fun is what I'm going to call that. So we just going to look here because I don't know what's supposed to be in that spot. So down at the bottom, we're given this equation, the f of x, that's how we read that, f of x. We will see this kind of notation a bunch. This is called our function notation. So anytime we have a function, we will probably write it like this. We'll work with this more in a bit. But we're given this equation here, our 6x minus 5. And we're asked to figure out if this is linear or nonlinear. What do we think? So remember, for something to be linear, we need to have no exponents other than 1. I could write it as a y equals mx plus b situation, and then it would be a line. What do we think? Is this a line or is this not a line? Think about when we have fractions like this. If we have adding or subtracting up here, I can always split this apart to make 2 separate pieces here. This is somebody has combined like terms by getting a common denominator. So what I'm going to do is I'm going to uncommon our denominator. So what if I put it as 6x over 3 minus 5 over 3? What this piece means, this whole f of x, this whole thing just means y. It's just being extra. I like to think of f of x as a really bad fake mustache. Like, f of x is y going, I am in disguise. I am hiding. It is the equivalent of a finger mustache. It is y. Y is f of x. F of x is y. He's just going like this and being evil. Mwahahaha. That's all he is. It's just y dressed up in a evil mustache. Whether it's f of x or g of x or h of x, any letter there, he's trying to be sneaky. He's not sneaky, but he's trying to be sneaky. Okay, so does this look more a little bit like the y equals mx plus b kind of situation? Yeah. And in fact, you could simplify this if you wanted to, because we could simplify this fraction. Oh my gosh, what? I could rewrite this to be y equals 6 divided by 3 is what? What if I wanted to simplify 6x divided by 3? What's 6 divided by 3? 2. So we've got 2, and then that x is still hanging out. Oh my gosh, right there. And then we've got our 5/3. So what do we think? Is this linear or is this nonlinear? This is linear. This is a line. We have a y equals mx plus b. It doesn't matter that the b is negative. It doesn't matter that we have a minus instead of a plus. We have a y equals mx plus b situation. So what we have here is a line. Let's look at the next one. Let's look at b here. We got 5y plus 4, or 5y equals 4 plus 3x squared. What do we think? Is this linear or nonlinear? How do we know it's nonlinear? We got a power other than 1 on a letter. Instant, nonlinear. No necessary math. We go, ew, There's an x squared. Nonlinear. Since this power is other than 1, we know it's nonlinear. If it has a power other than 1, it is nonlinear on a letter. If it had 3 squared, then it's fine, because that's just 9 being extra. Okay, let's look at the 3 graphs on the next page. So page 5. C, D, and E at the top. We want to decide if these are linear or nonlinear. So what do we think about C? Is that linear or nonlinear? Linear. This is a line. We can tell because if I hold a ruler up to it, it matches exactly. Ooh, that is a line. If I touch the screen, it gets grumpy. You got to be able to hold up your ruler to the whole function for it to be a line. So what do we think about B? Or sorry, D, the one in the middle. Is that linear or nonlinear? Yeah, it's nonlinear. It looks like I could make it if I had 2 rulers, or if I snap one in half, I could make this. It's kind of a V shape. Shut your face. The screen gets whiny when I touch it. So if I had 2 rulers, I could make that shape, but I need to be able to use 1 to make a line. So if it takes 2, not gonna be it. That was called an absolute value. We will look at that one another time. Thank you. So this one is nonlinear. What do we think about E? Linear or nonlinear? This one on the right. What are you doing with this one? Can I use a ruler on this one? It takes a lot of moving to get this to line up with the ruler. That is a very, very curvy piece. So is that a line? This one? I can't make it with my ruler. It's like if I have to bend my ruler, it's probably not a line. So that one is nonlinear. If it is not a straight line, it is nonlinear. Okay. Questions on any of these 3? We're going to do one more. I'm going to look at the example 3 that it has right there, which talks about Michaela working part-time, and she's tracked her earnings in the first 5 weeks. And she wants to know if there's a line for her equation, for what she's made. So we're going to have to figure out from this if she has a linear function. So we don't have a picture. We have some points and a very, very small graph. But that's okay. We can do that. I'm going to change my view so I can zoom in on that graph a bit, just so I can get it a little bigger. So we're going to use this graph to kind of help us figure out what's going on. We're supposed to graph the points that represent how much money she makes in the week. So we know on week 1 she makes $85. How can we put that on a graph over here? Where are we going to put that? Where are we going to put that? You want to put it here? Where are we going to put it? Direct me. One up, one up, right, left. Where are we going? Yeah. So above the 1 week. So we know it's at week 1 and she made 85. So X is going to be 1 because that says weeks. And then she makes 185. So somewhere up here, we're estimating. It's not going to be right on the line, but it's going to be pretty close. So we're going to put it there-ish. Whenever we are graphing by hand, we are getting an ish. We're not getting perfection. So then we have week 2. So we'll be above the 2. We're going to go to 119, which is a little bit less, but almost on 120. So our week 2, 119, which is up there on my thing, is going to be 120. So there's my 85. Then our week 3, 153, is going to be there-ish. Our week 4, 187, which is maybe there. And then our week 5, 221, which is counting by 40s, so it's going to be about there. So, now that we have some points up here, is there a way we could connect all those dots up? I could connect the dots. I can connect dots. Boop. Something like that. I'm good at drawing lines. Oh my gosh. I can connect them up. Is that going to be a linear function? Yeah. I think that looks pretty goddamn good, especially since we're graphing by, since we're graphing by hand. That seems really, really plausible to be a linear function here. So since there is a line that has all these points in here, her income is in fact modeled by a linear function. There you go. Sorry. Except to zoom in right. So since there is a line that contains all those points, her earnings can be modeled by a linear function. Since it's modeled by a line, because I can connect these all up with a ruler. It's right there. So if you get something like that that looks like a table, you can connect them up that way and do all that jazz. Okay? So for the most part with the linear functions, we're looking to see, does it have the things we need? Okay? Questions on that. Because that is all I have for you. Oh, I guess I have one listed here as due tomorrow, so I'll give you guys tomorrow. Oh, I have it up there tomorrow too. So today's the 5th. So 1 is technically due tomorrow. So if you have questions on it, today is a great time to work on it. We've got a little more than 10 minutes, almost 15. So if you have not done homework 1, now's a great time to do it or finish it. I'm also going to pass out homework 2. I know, how horrifyingly cruel. This will have things that we haven't talked about yet because this is going to take us through tomorrow as well, because tomorrow we're going to talk about intercepts. So I'm going to pass these out. I'm going to grab a couple of copies of homework 1 for my new friends. And then, yeah, if you guys have questions, now's a great time to ask them. Now's a great time to work on stuff. This is not the time for Instagram, TikTok, whatever it is going on. Because I'm old. I barely have a TikTok. You know, watch TikTok. Way too much, but I don't want to. Pass these down. So here's homework 2. All right, don't forget about the Canvas assignment that's also up on the Canvas page. Now's a great time to do that as well. You guys have some time. Ask questions, do things. Let me know how I can help. I'm happy to help. I would love to help. If I can help it.